Hey, everybody, wake up. Okay, so I've never been to the Philippines before. I've never met, I think, any of you before, but one or two people. So I'll give you a bit of an introduction on myself. I've been doing this since about 1999, not really in a professional context. My background is actually in mathematics. I used to work as a climatologist for the Bureau of Meteorology in Australia. I wrote the aviation meteorology system that actually covers the Philippines, that does all the weather for the planes. Since 2011, I've been focusing purely on security, and for 5 years I was the manager of Red Hat's product security team. I'm now working at Trustwave Spider Labs. This is my second week in the job, so I've got a t-shirt and everything. They've kitted me out. I have a few side projects, by the way. I do a lot of research into North Korea. I use publicly available satellite imagery and so on to get a lot of information about their nuclear program and about their networks, so if you're interested in that, I'm happy to talk to you about it. I'm also a free solo rock climber, so I climb cliffs with no ropes and no safety equipment, so I might die. Okay. This talk is all about some research that's come out over the last couple of years around new techniques, new vectors for achieving remote code execution against Java applications. So we're not talking about RCE in general, we're talking specifically about Java applications and specifically about RCE vectors that are related to deserialization. So what I'm going to walk you through is kind of a chronological journey, a journey through time of how we discovered all these issues and where we're at now. So we'll start with just explaining what Java deserialization is. I mean, I imagine everybody knows what serialization and deserialization of data is. We have some data in memory, you need to convert it into some kind of format that can be transmitted across a network. So that could be JSON, it could be XML, there's a whole variety of formats. Java actually has its own native deserialization format, or binary deserialization format, because it's a binary data stream. But there are also other frameworks available. There's various frameworks for XML serialization, so converting an in-memory Java object into an XML document that represents that object, and then back again. And there's a whole bunch of different frameworks, Dozer, Cryo, etc. for this. But basically, every single one of them is vulnerable to remote code execution. The bottom line, the one thing to take away from this before you fall asleep again is, if an application is deserializing untrusted data that's provided by a user via any of these mechanisms in Java, you can get remote code execution. It's just different ways of doing it. So we'll start with the easiest, most straightforward, and get to the more complex as we go. So as I said, there is a native inbuilt serialization mechanism in Java, but Java is very XML heavy. I'm not sure why. XML is awful, but they seem to like it, and so a lot of people want to actually use XML as their serialization format. There is a standard for that called JAX-B, which is exploitable in the same way as native. We'll get to that later. But there's also a whole bunch of other XML serialization implementations for Java. We'll look at two of them that are particularly vulnerable to RCE, one called XML Decoder and one called Xstream. And these are particularly interesting because they're used by quite a lot of XML REST API frameworks. So those frameworks where you just sort of annotate your code and say expose this via REST, expose that via REST. A lot of those frameworks under the hood are actually using XML Decoder or Xstream to serialize and deserialize the data so that any application that exposes one of these REST APIs can be exploited. One interesting thing about these XML serialization vectors, which is important later, that's different to the native, is that Java has this interface called serializable. It has no members, so it's just a marker interface. But if a class does not implement serializable, then Java's native serialization mechanism won't allow it to be serialized. One of the advantages of the XML mechanisms is they don't care about that property. Any class is serializable. So the way XML Decoder does that is really quite straightforward. You provide an XML document which includes a set of basically, how do I reinstantiate this object? Just tell me what object I should set up, what properties I should set, and then I'm going to have the object. So all you do is instantiate, a Groovy shell, and then tell it to evaluate a string. And it will say, all right, when I'm going to deserialize this instance of the application, I will do exactly what you tell me to do. So it's basically a direct code execution vector. You don't have to use Ruby shell, that just makes it easy. You could use java.lang.runtime.exec or any of these other things and just say, when to deserialize my object, execute the calc program or whatever. So let's do a live demo of that. What could go wrong? Okay, I'll just pop this down. Can I still use the icon? Alright, cool. So sorry it's a bit small, I couldn't make it any bigger and make it still fit on the screen, but hopefully you can still see it all. Okay. So this is an example using a REST API framework called RESTlet, which in vulnerable older versions would allow you to use XML decoder as the XML serialization mechanism under the hood. So what we have is this, Right, we have this class here called server RESTlets, and as you can see, it's implementing some authentication and authorization. But down the bottom there, about 5 lines from the bottom where it says router.attach/customer resource.class, it's basically saying let's bind that class to the REST API. And then what you can see here, we have the actual class that's going to be serializable. It's only going to print out hello world, it's not going to do anything malicious. But if you have a look in the README, what we're going to do here is 2 things. In one terminal, we're going to run the server. So now we've got a server listening on port 8182. That's our REST API. And now what we're going to do is run a malicious client against this, and boom, then we get the calculator app came up. And that's because, if we have a look at the payload that it used, all we did was pass this REST API an XML object which just said run calculator, and it did it. So XML decoder is a fundamentally insecure serialization mechanism because it just allows you to define an XML document that is a series of steps to run. So the fix for that was actually to remove support for XML decoder. I managed to convince the developer of RESTlet that you shouldn't do this. It's a bad idea. So there is no fix. It's just fundamentally an insecure mechanism for serialization. Next one up is Xstream. Now Xstream is much more interesting because it's very widely used. It is the most widely used XML serialization coder, whatever you want to call it, for Java. It's used by some very common and widespread tools such as Jenkins. It's also used by Server-type Nexus, which is the basis of the Maven repo. So at one time, there was a remote code execution vulnerability in the Maven central repo, which would have allowed an attacker to pollute jars that are used by every Java application in the world, and it was because of this. So one of the features that Xstream has that's really important is why it's one of the reasons why it's so widely used is its reflection-based deserialization, which would take a while to explain, so I'll spare you. But what it means is it's able to serialize and deserialize complex objects that involve proxy chains. So one of the things that you often do in Java applications is define an interface. So you might, the typical sort of textbook application would be you define the pour coffee interface, right? And you could have a class that implements the pour coffee interface by instantiating the brewer and then pouring it into the cup or whatever. Or you could just create a proxy, which says, whenever I get a request to this, pour coffee class, I'm going to send that request on to, I'm going to do something else and get the response back for you and proxy that result for you. And Xstream enables you to serialize and deserialize these dynamic proxy objects. I encourage you to read up about them to understand it better. And other serialization mechanisms don't. So that's one of the reasons it's widely used. So, what can you do with these dynamic proxy instances? Well, here's an example. So we have a tree set, right? So a tree set is just a sorted set. And then inside of that tree set, we have an object. So it's just a tree data structure. We're storing an object in that tree data structure, and it's going to implement the comparable interface. So anything that's in a tree set has to implement the comparable interface so that you can compare the objects to one another and sort them from A to Z or however you want to sort them, right? And then what we're going to do is use this invocation handler, which is part of the dynamic proxy, called event handler. And what event handler does is say, I'm going to implement this interface, but I don't know anything about that interface. It could have hundreds of methods on it with all kinds of different arguments, and I don't care what they are. Anytime any one of those is called, I'm going to do whatever you tell me to do. So we create an instance of the event handler, and we say whenever anybody calls any method on you, what I want you to do is go and run some command. Even if it's a PDF viewer, I was using that for Linux, so I use a calculator on Mac. So my new job made me use a Mac. I don't know what's wrong with them. Anyway, so, and then we just pass in the argument start. So basically what's going to happen when it deserializes this XML document on the server side is it's going to say, oh, okay, I've got a tree set, and it's got a member, and the first thing I have to do is compare that member to sort where it is in the list. And when it runs the compare to method, then it will pop events, calc, whatever command you run. So because you know that any time a tree set is deserialized, it has to compare the members to one another, you know that your code is going to be executed. You don't rely on any other condition. So an example of this is in Jenkins. I guess a lot of people have heard of Jenkins, a continuous integration system. And it's got an XML API that uses Xstream to deserialize input. So when it was vulnerable, it's now patched, you could provide a malicious request to the Jenkins XML API, and you would get remote code execution, which has very serious implications because usually Jenkins is used to actually produce the build artifacts of software. So if you've got code execution on the build system, then you could pollute the build artifacts and produce, it's got wide-ranging implications. So I'll give you a live demo of that. So I'm just starting up Tomcat here with Jenkins in it. It's probably going to pop out a couple of times because I exploited this earlier, so just ignore that. Okay. And by the way, I'll put all of these exploits up on GitHub, so if anybody wants to play with them with the README files and everything, you can. But basically, all I'm going to do is make a request, like this one here, to the REST API, and I'm going to provide malicious XML as the input. And that is exactly what you saw earlier. The only difference is I'm calling calculator rather than events. So I'll just put that in shell script, and there's my calculator. Okay, so yeah, when I was working at Red Hat, I did a write-up on this. This was about 2014 that this came out. Like I said, this is kind of the step through time. So there's a much more detailed write-up there on the Red Hat blog if you want to read it. Which gets us to our main topic, and this gets a bit more complex here. These XML serialization mechanisms have largely been fixed because in the case of XML decoder, you say, look, it's broken, don't use it. In the case of Xstream, there's kind of this one special class, event handler, that makes the whole thing exploitable. We haven't been able to find anything else that makes it exploitable, so they just blacklist it and say we won't handle event handlers. So far that works. Binary deserialization is completely broken and cannot be fixed. And we'll get to this, hopefully by the end of this presentation. So, the native serialization mechanism doesn't have anything that's so obviously exploitable as the XML serialization mechanisms. But what it does have, like I said, classes that are going to be serialized this way have to implement an interface called serializable. And that doesn't make them do anything. You can just say implement serializable and you're done. But it includes two optional methods that you can override, called readObject and readResolve. And these are called at two different stages during deserialization. So if you want to do anything special, you want special deserialization logic that does something, that writes a log file or whatever it does, every time it's deserialized, you can put code in there and it will be executed at deserialization time. So what it means is, if there is some sort of exploitable condition inside those readObject and readResolve methods, then you could get some kind of impact. But there's two things here. One, you need to have some exploitable condition in readObject or readResolve. And two, the attacker has to be able to provide binary serialized objects that will get deserialized. It turns out that's really not a problem at all to do. There are so many ways that this is used. So many different back-end services and so on that accept binary serialized data. There are, pretty much all of the major Java servers, JBoss, WebSphere, etc. They all do it. There's a lot of web frameworks that do it. So, for example, Rich Faces uses it to maintain state. The client and the server are sending back serialized objects to maintain state. RESTlet, the REST framework, can also do it for REST APIs using native binary serialization. I'll skip that demo. So, what issue could possibly exist in readObject or readResolve that would be exploitable? So, skip back to 2013, and I was working at Red Hat with my friend Arun, and we're there one night, it's like 6 p.m, we're about to go home, and we get this email to the sec alert box. It's entirely in Japanese, and it's from this guy called Takeshi Terada. And I was like, wait a second, I know that name. Google it, and he's got a bunch of advisors, very low profile guy, but he's got a bunch of advisors, and they're all critical RCE bugs, they're all brilliant bugs. So I was like, all right, we can't ignore this, let's send it to the Japanese, we had translators, in the company. Let's send it to the translators and figure out what's going on here. So we sent it to them, they translated it, and it was very simple. It was basically like, I have a remote code execution bug in Rich Faces, here's an exploit. Here's a proof of concept exploit, which was a binary exploit. So, long story short, it took us about 48 hours to finally figure out what was going on. And he had two distinct bugs. One was the fact that Rich Faces was deserializing content, so that gave you the vector in. The other was that there was a class on the class path called commons file upload. And commons file upload would allow you to specify part of the file path in the object, and then it would add stuff on, to make it, to put it in a temporary directory and make it unique. But it turns out that in the low level of the JDK, this was all actually native binary stuff, so you could do a poison null byte attack to truncate the string of the file name, and then as an attacker, you could write a file to an explicit location, so you write shell.jsp to the web root of the server, and now you've got RCE. So that was a bit of a mindfuck. And we fixed it. We fixed commons file upload. Oracle patched the JDK. Only time ever Oracle responded to me about anything. Not that I'm bitter. So after this happened, everything sort of died down a bit, and I started doing a bunch of reading. By this point, I was really fascinated with all this stuff. I thought there's more to this. This isn't the end of the story. And went back to, dug around, went back to 2011. First known instance of this kind of issue, the only one prior to Takeshi Terada. And it was Raza Kokart's And what he found here was something very similar to what we exploited with Xstring, right? That you have this invocation handler exposed where you can say, okay, I'm going to serialize proxy, and anytime any method is called on that proxy, no matter what it is, it's going to execute what I tell it to execute, put it in something that gets sorted, and you get your code. And the key thing here was that invocation handler was serializable. So event handler is not, so it's only exploitable with Xstring. But because this one implemented the serializable interface, you're able to actually exploit it. So again, there's more right up there if you want to read about it. So yeah, this is the issue that we actually found from Takeshi's report, was commons file upload. And the disk file item class, it would allow you to specify temp dir, but not temp file name. So you could write something into the web group, but then it would go and give it a unique name that didn't have a .jsp suffix, and because of the poison nullbyte, you could truncate it and get it. So there's a few ways that you can fix this here. Obvious one is don't deserialize untrusted content. But that's hard to solve because if you've built, for example, a whole web framework where the entire state mechanism is based on syncing serialized data, or a lot of these, bank-to-bank messaging systems where they're implementing a message queue and they're sending serialized objects to each other, you can't just turn that off. So it's a bit, reluctant to say that's the fix. It seemed like an easier fix was don't introduce flaws in read object and read resolve. If you don't have any flaws in read object and read resolve, you're all good. So I took the stance that that's where the vulnerability is and that's what you have to fix. I was wrong. A final way of doing this is type checking with look-ahead deserialization. So if you know disk file item is vulnerable, you know event handler is vulnerable, before deserializing the whole object, you start inspecting the data stream and say, oh, that's an event handler, I'm not going to touch that. And Pierre Ernst from IBM wrote some proof of concept code for that, which also works. So, going further with this is where it sort of ended in 2013, 2014, and I started continuing on with my own research, saying there must be more vectors here, there must be more ways that we can attack this. And I found this thing called Dozer, and Dozer is a type mapper. So the idea is you might have two different systems. So you've got two different banks, right? And one of them sends an object that represents somebody's account, and the other one has another object that represents their account. And one of them's got a property called balance, and that's how much money you have. Or the other one might have a property called available, and balance might be an integer, and available might be a floating point, right? But they both represent the same data. And you should be able to, the two objects, you should be able to transform one into the other, right? By defining some rules. So Dozer is a mechanism that allows you to do that. And it also allows you to transfer between types. So I might get one account as XML data, another account as binary data, and you can just write some rules to this plugin and automatically convert them. So I thought, well, hang on, this is a great vector, because if you've sort of got this open window saying, I will take any kind of serialized anything and convert it into something else, then maybe I could exploit that to, that's a way that you're going to deserialize binary data, even if you didn't think you were going to. But the problem here was I needed something that implemented serializable and was exploitable. I was back to the same problem. I had a way to deserialize untrusted data, but we patched all the known vulnerable classes. So I needed something new. I needed something new that I could exploit, and ideally get some kind of invocation handler that implements a serializable interface. I was able to prove that this actually worked by using the original one, the Spring OP one from Router, and demonstrate that this was in fact exploitable. But I didn't have a class. I didn't have anything new. I said, if you've got one of these old vulnerable classes, Dozer is totally vulnerable. And so I was able to get a CVE. I reported it upstream nearly 2 years later. It's not fixed. There's no patch. Lots of people are still vulnerable. If you find any application using Dozer, it is vulnerable. And again, I'll skip the demo because I don't want to take too much time. running a bit late. So, summary at this point, this is the end of 2014, start of 2015. We have increasingly more and more ways, other ones came out, not that I found, that other people found, that yes, we can deserialize untrusted binary data, but we don't really have any vulnerable classes. We know about a couple, but most people have patched them, or they should have patched them. So we need to find something new. And I went through all these invocation handlers in the JDK, because these are the things that work with proxy objects to enable you to somehow map them to another object. And we knew event handler was exploitable, but it's not serializable, so I can only use it with XML. Do we have an exploitable serializable invocation handler? So we went through sort of the other ones that are there in the JDK, and sort of got there. We went through the MD servlet invocation handler, which enables you to proxy a call on one object to a call to a managed bean in a J2EE container. Now this is exploitable because we need to figure out the JMX URL to that managed bean, but we can get it. Either it's exposed locally, or we can just brute force it because you can specify a JMX URL via PID. It's a finite number of process IDs, so you just brute force them. But it's got a big problem. With Event Handler, what's really cool about it is you can just say, I'm going to proxy you to any object, any type, I don't care what it is, and whenever you call any method on that type, it's going to do this one thing that I tell you to do. So we don't rely on the server doing anything special after it's deserialized it, and we can force it by making it do something like compare objects in a tree set, and then we know we get our exploitable condition. But we couldn't do that for mbeans because it just maps one-to-one. You say, oh, we've called the, drink water method on the cup object. Well, I'm going to, proxy that to the drink water method on the managed bean mouth object or whatever. And so I couldn't force that mapping. Exactly the same problem for a mode object invocation handler. Again, it's a similar kind of thing to a managed bean. You could get the JMX URL, you could find a remote object, but you have to then rely on it making specific certain calls to exploitable methods after deserialization, and that's way too hard. So it doesn't really count. Skip to late 2015, and this great work came out called Marshall and Pickles, Chris Frohoff and a bunch of other people in the US, and they came out with a whole bunch of new exploits for this. And what they proved was that pretty much if you are deserializing binary data in Java, doesn't matter much what's on the class path, you can get RCE. And the way they do that is they call it property-oriented programming, and it's similar to return-oriented programming. So instead of like that very simple case of the disk file item where you've got a poison null byte for, or event handler where you can just directly tell it to execute code, what you do is you assemble a complex object graph where there's going to be cascading calls to read object and read resolve as it deserializes the graph. And then you exploit multiple conditions in this whole chain to eventually land you at RCE. And they found that there were so many different kind of combinations of objects that could do this that they could find one for pretty much any vulnerable server. And so they called these gadgets, these chains, these graphs of serialized objects. And they found one in a library called Common Selection. It's quite complex to understand. I'm not going to go into it. Feel free to read about it if you want to. But you'll need to know some Java internals to understand it. But what they do is they provide you with, it's almost like a Metasploit module, like a weaponized payload. Here's this serialized object, plug in your command execution, and eventually when it gets deserialized via call to call to call to call, you will land in RCE. And the thing about Common Selection is it's in nearly every Java application in the world. It's just a fundamental building block. Everybody uses it. So they're able to show that this could be exploited everywhere. All of these servers, JBoss, WebSphere, Jenkins, WebLogic, they all include Commons Collection. So they fixed Commons Collection, but then they found one in the JDK itself. So, there's kind of nothing you can do about it at that point. So at this point, what do? We've found that tons of things are deserializing arbitrary content. It's complex to fix it. And they've got this YSO serial tool they've used to aggregate payloads. It's kind of like the Metasploit of Java deserialization vulnerabilities. So even script kids can exploit it now. You can use that look-ahead deserialization mechanism to inspect types, but that's kind of a losing battle because you have to just keep maintaining a list of what types you're looking for as more and more come out. As I said, if we had a gadget entirely in the JDK, it doesn't matter what's in the class path, that's now come out. So it's kind of game over if you're deserializing content. And here's the thing, I was wrong. Back when I was assigning CVEs to these things, a couple of guys at the Apache Software Foundation disagreed with me. There's this one guy called Mark Thomas who's like I hate Mark Thomas. Anyway, so he was saying the vulnerability is not in this class, the vulnerability is the fact of deserializing content. I had this big flame war with him. And anyway, I was wrong. It turns out that, yeah, the vulnerability is actually deserializing arbitrary content. And as this tweet says, it's very similar to ROP, if you understand anything about ROP. It's a very interesting field. So that's it. Any questions?